I'll start at the top. So obviously Docker, everyone knows, works well for stateless, immutable sort of applications, but obviously state, there are quite big challenges to running stateful services or containers that require persistence of state. What would you say the biggest challenges are when it comes to running those in production? Who wants to start?
I'll take that. I mean, I touched on this on my talk, but the moment you write anything to disk, it falls off this idea of 12-factor rescheduled, magically repairing whilst you're asleep challenge, right? So anything is written to a disk, and that server becomes very special. And so if you don't have something in place that understands A, that that's a problem, and B, can work with that problem and is cluster aware, so it knows about all the servers in your cluster and can start to deal with the state that's on the disk and be capable of repairing the situation where that node goes, then that's a real problem. Because the guys, your visitors to your website come 2 seconds later and there's no data there. That's probably the biggest problem I can think about in running applications on the web. So I think you really do need, and I'm going to try and not just pitch Flocker on this panel, because that was pretty cheeky, but something like Flocker is the sort of thing you need to at least start to think about. So there's lots of other solutions. Like you could just use a distributed file system and mount the volume onto that distributed file system. So there is another solution to take. It's not Flocker central, but it's certainly a challenge to think about a container that is bound at the hip to the server that it's living on, which goes against all of the things that we're being told about this magical new world full of unicorns called scheduled across 1,000 nodes and you can sleep all night. So I think the main problem for me with stateful containers is handling what happens if the node goes down that the state was written to the disk on. That would be, yes.
And the assistant call for that would be?
Say again?
An assistant call for that is?
Oh, fsync.
So yeah, I completely agree.
Yeah.
Barry, Matt, anything more to?
I was like, I don't know. Of course, it's obvious.
Yeah, no, I think you touched on it earlier. I think one of the biggest challenges at the moment is storage and networking, as far as we can see. And I think a lot of people have been using it in production. That's been the real barrier at the moment. Networking will come next, I think, which will.
Network, sorry, sort of. I think we're around the verge.
I would say it's the other way around. Like I think the Calico is represented here in the corner there, and those guys are in the real kind of the exciting part, scheduling and networking. Everybody wants to think about this stuff because it's like, hey, I can throw stuff around, but how does it speak? And storage, we'll think about that later. Maybe because of this legacy of 12-factor, like let me put it another way, 12-factor, how Heroku would like you to write your app.
Yeah.
That's something I've thought about in the past, right? Where, hey, just like don't write state in your app. It's almost like you've got the leprosy if you write state in your app. And I think that perhaps in terms of timing, at the moment, scheduling and networking are the hot things, right? And storage in our play at Cluster HQ is to wait for the time that everybody realizes that storage matters too. So in terms of like the ordering of these three things, compute, networking, that's the current focus, and hopefully, anyway, storage will become a main focus in a year, 18 months, something like that. And
I think that's a fairly safe bet. I also think that the barrier to entry on storage is really kind of why it hasn't been touched as much so far. Right? Which is that
it's harder, basically.
It's a lot harder, yeah. Because just like I said, which is like it's writing at the end of the day, it has to end up on some actual physical hardware somewhere, right?
Mm-hmm.
That may be through layers of EPS and through all this other thing, but it actually has to end up somewhere. You have to do all the error checking. You have to make sure that you've done it correctly, and doing it correctly is not even hard. I glossed over it a little bit, but locking, I say it locks the thing, it syncs the thing, unlocks it, right? And doing a distributed lock, I mean, okay, yeah, no, we've got that, right? Like etcd does that, but so there are things that are still relatively new in the ecosystem, relatively speaking, right? Like Docker thinking about having some consistent store out there. Kubernetes is touching on it with some scheduling, so there's Mesos, I'm sure. I don't know, yeah. But in general, it's harder. That's right. And so networking, I think is actually coming along. There's both Calico, and as I was going to mention, the Weave folks and the Flannel.
Of course, Flannel. Yes.
Yeah. So, which is in the work of one.
And dare we
great
say
guy.
socket plane, aka Docker now? I mean, I always thought of it as the three networking people, and there was Weave, Calico, and socket plane, and now it's Weave, Calico, and Docker, because obviously socket plane got bought by Docker. But I think you're totally right there. Something I want to ask you actually, etcdfs.
What about it?
That sounds like a really useful combination of like a file system but with consensus.
It could be interesting for a very small data set, like or very small is gigabytes.
Mm-hmm.
With the new, so actually we just last week did the 2.2 release with the V3 API sort of beta.
Did you just define small data? Is that what just happened?
Actually, yeah. I think I'll take credit for it.
So small data, tens of gigabytes, everyone.
But the important thing about those tens of gigabytes, those are the tens of gigabytes that define your cluster, right? These are the things you really need.
Yeah.
Like a lot of this, big data can fall into two categories. I've seen them both. One is sort of very time-sensitive data, things that you're getting quick counts or you're getting whatever. And then there's just huge masses of stuff. That's video, the internet, archive, whatever it may be.
Video is going to be the big one.
Video is a good example because it's something that people can upload. It's something that's sizable enough that it's like okay.
I was literally speaking to somebody today, and they deal with IFC files, which is like a geometry format. It's called BIM. It's like how architects share their designs with each other, and they were like, they're really big files. It's like, I'm sure video is slightly bigger though than geometry. I mean, it's kind of big though because to describe these huge geometry points, there's a lot of data in there.
But what's usually interesting about that is as time sensitivity kind of goes up, the need for serializability and sort of consistency goes up.
Yeah.
And as it becomes more just kind of long-term storage, you don't care if it's 5 seconds or 10 seconds as much.
Yeah.
So there's some interesting opportunities to play with that time scale. And
so it's like a trade-off as to your use case, as to the timing versus the consistency guarantees.
Exactly.
Yeah, that makes sense.
And that's something that is sometimes application specific, sometimes a lot of things. So it's hard to pick exactly the right trade-off. So.
Cool. And a lot of the talks around what Facebook do is exactly around that, which is around trying to put it in a storage medium that reflects its usage. So my blog post my post that I've not seen for months.
Hot and cold storage, right? This is what I've heard.
So it's kind of tiered, and actually I think that tiering will become pretty interesting.
It's interesting. So that's not just the type of content; it's also how immediate freshness.
I think actually they actually use DVDs.
Right.
Honestly, Blu-ray, if that's right. Can't get with the times. But
well, maybe Amazon Glacier is like a nod in that direction, isn't it? Like, hey, if you don't want it quickly, then we won't charge you.
And in general, thinking about storage, maybe instead of 3, maybe we're getting the 4th and 5th layers of this 3-layer app thing, which is sort of the load balancer of the app, and then time-sensitive data, and then not at all time-sensitive data. Maybe very sort of rough split.
Great. Thanks very much for that. Just moving on to the next question. So I've got a database background, MongoDB, Barrick.
Sorry.
And we have actually been out, obviously on the road, talking to customers about why they might want to containerize their infrastructure. And some people say to me, well, why on earth should I containerize a database? Do you think there is actually any value in putting your database in a container? And if so, why do you think that is? And I know, Matt, you've got some ideas on this, so do you want to kick off?
I think hopefully you guys can say yes, and you might do. I think the obvious is yes, because effectively a container is, as we know, it's just a process. It's a user space process, which is effectively a set of files. The nice thing about it is you get isolation. So if you're trying to run multiple instances, you can actually isolate them effectively. You can place controls over the use of the resource, so CPU, RAM, storage, everything else. So I think the ability, if you're running something multi-tenant and you want to put it on bare metal, containers seem a pretty good way to isolate it, short of using a very heavyweight kind of virtual machine to do the same thing. I also think the scheduling, which you touched on, is really important. Because actually, the likes of Kubernetes or meetups can actually make pretty smart decisions about where to place your data.
Like unique constraints and these sorts of things.
Yeah, it's like I've got a database, it's got to run in 3 regions, I need it to run on an SSD, go do it. I don't want to care about having to do that kind of work and actually maintain that state as well. So I think some of that will be really useful to do a database, and particularly to a distributed database. The number of customers I came up against that needed that was immense. So yeah, I think it really works. I mean, why not effectively?
Yeah,
but then the question becomes how to get the storage to work.
Yeah.
Indeed.
And then these challenges kind of present themselves. But no, I think some really good reasons to use a container.
No, I totally agree with that. I think I look at a database as a process that writes to disk, right? That's all it is. This idea that somehow it's special. It is pretty special because if it breaks, you're screwed. That's why it's special. But what is it? It's a process that writes to disk. So let's split those two parts. Let's split those two things apart. It's a process. What's really good at managing processes, for all the reasons a lot of you have probably already know, is this a question? Are we allowed to take questions now?
Yeah, of course.
Yeah,
you're live.
Yes.
So a database is a process that writes to disk, but they're a little bit unicornish, right?
Mm-hmm.
Page cache matters in a database,
Mm-hmm.
right?
Mhm.
Because most databases now don't try and implement that. So when your process dies, you boot up a machine that's cold,
Mm-hmm.
right? And on big databases, that really matters.
Yeah.
Yeah.
So do containers really give you anything when they
Sorry.
I think I'll
Yeah, that's
finish with
good.
this one, which is, yes, it entirely matters for performance. You're exactly right about that part. The thing that I think is interesting about why is the scheduling opportunities is really the cool thing about containers, right? And if we already assume, even if you're running a standard sort of master replica setup, right? Nothing too crazy, not even a distributed world, just talking about having something which is hot, though. But you have some portion of it which is warm, which is set up, which is ready to go. Running it within a container, if it is just a process, now I agree with you on that, it's just a process, it should be containerized, that makes sense. Multi-tenancy, some amounts of disagreement there. But anyway, point being that there's an opportunity for the scheduler to make a decision which is basically this thing should have free reign over that box, or this machine should have as much RAM or page cache or whatever it needs to complete its job effectively. And so then if you have multiple replicas, hopefully one of them is warm. And you're booting up a cold one, and maybe you don't point the load balancer at it immediately. Or maybe you do, and you kind of let the cache warm up and just kind of accept that your 95 percentile is going to go a little high for a little while. But it's all trade-offs, but I think there is some value in it, if only for the scheduling opportunities, which is the direct answer to the question.
Great.
And I think you still get that with a VM anyway. If you're bringing a VM in cold, then it's also the same problem. So
I think
there's a variety of methods that you can use to mitigate.
Maybe something to throw into the answer is containers don't remove anything from the situation. Right. And so let's look at, if it had a huge downside, then it's a trade-off, and let's talk about which option. But I can't think of a reason not to run a process in a container unless it just won't work. So the process side of stuff, that is. And so what are the advantages? If we're agreed, which I'm not sure we are, but let's just go on that premise that containers don't remove anything from running the process inside the container versus on the host. All the advantages that we probably all are quite aware of are there for the taking. And so the summary might be why not? As long as, let's say, you either have a distributed database or something like Flocker that knows how to move the data. So let's not ignore the fact that it does write to disk, but let's separate those two parts. And why not run the process in a container? There may well be some speed impacts that I'm not aware of in terms of kernel layer. I don't know.
Yeah, there probably will be.
There's probably something that is a disadvantage. That would be an interesting thing to throw out to the crowd.
That was exactly what I was going to talk about. Most of the people are going for database running bare metal, even that just to get the best performance that we can.
Yeah.
So especially because of database, they're writing as much disk, and they need to actually have that speed improvement. So any delay that you put on database is going to have a huge impact on the response of the queries and all this. So again, it's about this trade-off that you are doing. You're putting another layer of complexity on top of that. So I think maybe for databases again, and imagine that you lose a disk and you spin up a new container on another virtual machine, and this virtual machine then you need to move the disk to these other machines. Normally database has huge disks, and moving this data across is going to take a long time. Just something maybe it's not.
But I don't know.
perfect.
It depends if your disk is local storage or network attached, etc., etc. So, but you're right. I think that there's it's a trade-off, right? And I think if you're running something that's time-sensitive data, then that trade-off is going to matter much more than if you're just saving order records that are almost like asynchronously recorded. So I think that there's huge advantages to running any process in a container. Spin up time. The idea you can apply updates much easier because it's just pull a new image rather than have to try the mutable infrastructure, etc. But no, I think the real summary is look at the use case, look at the speed, measure. This is the thing I've learned from my much more clever engineering team than me. Measure things and then make decisions. Like, hey guys, this is a great idea. Have you measured it? No, then go away. This is what I've learned. So I think this might apply to this question here, without there being one single answer.
I'm always yelling about measuring too, so I'll definitely agree with that point. I also wanted to say that another thought would be, sort of, hopefully I touch on a little bit, but fsync as being sort of a lie, right? It's at least a nice hand wave that we kind of depend on, and it works 99.99% of the time, right? Doesn't always read that article is a really good one, but that there could be some opportunities for having like a local SSD backed by some large distributed storage, say. Have some way I call an fsync and that fsync returns because it's really just talking to the SSD, but then it kind of replicates out. And for 99% of the time, that's good, but then again, what happens when it fails? And these are all things that need to be measured and tested and built, so.
I think the local SSD is an interesting one. I think Matt might have something about that. But yeah, that's a challenge at the moment, which is, and yes, you guys are kind of aware of, which is if you want to run a database in a container, clearly you want to take advantage of local fast SSDs.
Yes.
And that kind of presents a challenge that if something dies and the container process dies, you need to kind of reschedule. Yeah, indeed. Yeah, you need to reschedule that somewhere where it hasn't got that. So clearly that's a problem. I know you guys have got ZFS.
We do. We have a ZFS backend, and ZFS is awesome. I'm a big ZFS fan, but we're not kind of like pushing that as a production-ready thing. It's still in experimental phase, but it's an entirely different use case to the one we saw with the demo, where the storage is over the network EBS attached to volumes. This is local storage taking SSD to its full potential, and using ZFS snapshots, you can migrate the data to elsewhere, but it doesn't deal with HA, right? The node blows up and your data's gone. So. And then you're on to distributed databases, which is the middle ground between these two things. And again, can I shrug my shoulders and say, I don't know? Is that okay sat here? But really then my defense to that answer is measure all the different things and then choose. And so I don't think there is a golden bullet. Yes, you should run databases in containers. That's not the line. However, if you're able to, then you should. Yeah, I think there is a nice middle ground to that question. Ask the next question quickly.
Well, just to open I'll open it up. Has anyone got any burning questions they'd like to ask?
Yeah, but
please.
from the talk, definitely.
Yeah, so you were talking about Flocker earlier, and you had Mesos and Marathon up there on the screen. Flocker wasn't running in Mesos and Marathon. Is there any reason for that?
It's a great question. Again, I'm not sure how much of names I can say. So let's just say we're currently contracting a very well-known Mesos consultancy to write a framework for Flocker. And so we're very keen on having Flocker running in the natural way that things should run in Mesos. What you just saw was nodes running the Mesos slave and the Flocker dataset agent side by side on the host. So I
the reason that couldn't be running in a container scheduled by Marathon rather than
there is absolutely no reason for that because that couldn't happen. Sorry, because we literally maybe 3-4 weeks ago we did a blog post that demonstrated Flocker running inside containers, and I mean it'd be really great to grab that. And why is that hard? Because inside a container your mount namespace isn't the same as the host namespace, right? So Flocker is all about mounting volumes onto the host. That's what it does. If you run Flocker in a container, the mount namespace has no relationship to the host anymore. It can't just mount stuff on the host. So it was a real challenge, hence us not having launched with Flocker in a container, otherwise we would have done. So take the Weave guys, for example, they just run Weave in a container because they're using PCAP and user space routing, etc., etc. But we just we couldn't do that. It was impossible because from inside the container you can't get to the host namespace. So we found a hack. It's a horrible hack, but it is the same hack that Kubernetes is using to get around the same issue, right? And so when Rob was like, I found an amazing hack around it, and for about a month I'm like, wow, Rob, you're really clever, you found this. And then I went on to Kubernetes, I found the issue, and it's exactly the same thing Kubernetes is doing. I said, Rob, you you noticed this issue, didn't you? So what's the hack? A quick explanation. Like from inside the container, you're in a customized mount namespace, so you can't touch the mount on the host, right? But there's a tool called ns-enter, which is the same thing that Docker exec uses to switch namespaces from where you're running stuff. And so from in the container, we're ns-entering to PID one of the hosts having mounted /proc into the container. It's horrible. It's horrible.
Also, pro tip for security: don't do that.
We know this. It's all over a blog post. This is a POC. It's a demo, etc. Right. However, like here's where actually it starts to become something that is laying the groundwork for how this will work is Docker configurable namespace flags. So at the moment it's using the sort of private namespace for mounts, and if you had a shared mount namespace in the container, then now it's able to read and write from host namespaces properly rather than this horrible ns-enter hack. So to answer your question, what you saw there was Flocker running on the host alongside the Mesos slave running on the host. To run Flocker in a container, we need a proper version of this mount namespace solution where you can say, hey container, run, but the process running in the container can still modify the mounts on the host without this horrible hack, which is, I have to say, something quite useful to get the proof of concept working. And now all we're going to do is switch the way in which the mount namespace trick is working to the proper way, but the pull request is still sat there on Docker's list of stuff to merge, and we're back around the loop of trying to hit Docker on the head with a hammer like we did with the plugin. I'm trying to not be politically bad here when I say that stuff. Sorry, Baron.
Incidentally, this is why I'm not big on multi-tenancies, for or at least, especially when you're talking about tenants who don't know about each other.
Yeah, no, I don't agree exactly with that. I think if it's a friendly tenant,
yeah, exactly.
and you're running sets of dev databases, test databases,
Sure.
in that same environment. But no, you're right. VMs are really going to be probably pretty necessary.
Does that answer the question?
Yes, and then the follow-on question is, if you're then running natively on the host, what do you do with your state? Because you must then be running a Docker hub, Docker daemon next to the Docker daemon, next to the Mesos daemon on every Mesos slave.
So the state, do you mean Flocker specific state?
Yes.
So the Flocker has one control service at the moment, and it's not HA, and I can't bang the drum about how many times people ask me, what is Flocker HA? And when I say, well, not at the moment, and hence actually why I mentioned...
It could be etcd backed.
Well, this is why I mentioned etcdfs, because it's such small state. Like Flocker hasn't got, it's kilobytes literally, and it writes
most
it to
of
a
this
JSON
really
file.
important state is, actually.
Exactly, there you go, right? But it is very important. It's like top grade DEFCON 1 state in a JSON file. And so at the moment...
Set an etcd cluster, put it in it.
Well, this is exactly what we're heading towards, right? So to answer the question, at the moment Flocker's not HA. There's one control service. If it goes down, that is a problem. You could always put that state on an EBS volume or write it to etcdfs, which is something Majuri, one of our engineers, is working on doing as a way around it. But as a proper solution, the control service itself, so the dataset agents don't hold state, they're stateless. There's one process that holds the state. And the ideal solution would be for the control service to, rather than just write to a file, actually write it to etcd or console or Zookeeper. I think they're still making a choice over which of those to use. So where we're heading is to write our state to a proper distributed consensus-based data store. And then by nature, the control service is stateless. The state lives in, well, where it should, which is in one of these tools like Garrett writes. Is that
Cool. So I just want to wrap up with just a short word from you guys. So we're at the stage now, there are obviously issues to iron out around container storage. Where do you see us in a couple of years with this? Where do you think we're going with container storage? So I'll start with Barry.
Start with me? Oh man.
It's a hard question, isn't it?
Well, that's a hard question because you asked me to predict the future. What do I see in the future? No, in all seriousness, I talked a bit about it, which is that I think that kind of at the end of the day, whether it's EBS, whether it's whatever it is, we have some way already of writing something locally to disk. This works fine. And then we need some way of kind of unifying all of these into one kind of global mount point /disk / I'm not exactly sure what. But whether it's on bare metal, whether it's on AWS, whether it's on, pick your poison, it should ultimately look like some mount point to the cluster at large. And again, the way it does that is through consensus and availability and that sort of thing. but yeah, I think that my guess is, and this is then just a prediction, and there are no plans. I'm not, don't hold me or Chris or anybody to this. But I would say that probably in 2 or 3 years, most of like Mesos or Kubernetes or stuff will support some notion of, here's where our storage layer is. Here's the storage layer we provide as part of our implementation, actually. And I'm saying it's actually going to be at the Mesos or Kubernetes level because that's where they have the best opportunity to schedule where the data is, and knowing that, and therefore interfacing with whatever store that may be. And
that's a decent.
I think schedule where the data is really interesting.
Yeah.
Particularly if you're doing some kind of analytics, you want to spin up your container that's going to do the compute in the right place. So rather than moving the data to the application, you can.
Which is almost always the best way to do it.
Yeah, and I think the scheduling is not quite there yet.
No, absolutely not. But given another 3 years.
Yeah.
Exactly, in that kind of time frame, I think you can have some pretty smart schedulers that will be doing that task.
Yeah.
See you next time.